Hello, everyone, and welcome back to the Climate Health Data Science Workshop series. I'm Achi, and in today's session, we'll continue our analysis of heat index value in Ghana, but with an shift in our approach. So instead of working with polygon boundaries as we did in previous exercise with rasterio, in today's session, we'll focus on extracting data for specific point locations. And in this case, we're going to use the DHS survey cluster points. So to begin with, let's first set up our Python environment. And similarly to before, we'll need several key libraries for this analysis. So NumPy and Pandas for data handling, GeoPandas and Shapely for geospatial operations, and Rasterio for working with our heat index files. And also, we're going to import Matplotlib for any visualization we might need. So once we have imported our necessary packages, first, we're going to access our daily heat index files. And we will construct our file path using the OS path join function. Here, again, we're saving this under the data folder and under the HIMX 2016. And here, we're using the wildcard to select all the TIFF files and to sort it. And we can print the first 5 files to check if they are in order, and we can see that they're starting from January 1st. And now moving on to our DHS cluster data. So the DHA cluster data represents household survey data that are aggregated at the cluster level. And compared to our zonal statistic analysis before, here we are working with the cluster points rather than the polygons. So each cluster in our datasets combines multiple household records that share the same geographical coordinates. And for our heat analysis, the data has been pre-processed. So the numerical values were aggregated using the mean, while most of the categorical variables were removed, except for the rural, urban, and country classification. And here we're loading the CSV file, and then we're dropping on the records where both longitude and latitude are 0. And after we've done the data cleaning, we can print the first row of our data set, and now we can see that we have the longitude and latitude for the cluster and also their rural urban classification, and also the mean of the numerical variables that we have before. And we can print the length to check how many DHS cluster that has been surveyed. And in this case, we're working with 423 valid cluster points across Ghana. And finally, we will add a unique identifier to each cluster. Basically, we're adding an ID column. And this might seem like a small detail, but it's actually quite important because we don't have an identifier for each unique rows. So this ID will allow us to easily join our heat index value back to the cluster data later in our analysis. And now, once we add the cluster ID column, we can also check again the first 5 rows, and we can see that we indeed have the ID column starting from 1 in ascending order. And now we'll transform our DHS data into GeoPandas data frame. Because although we currently have the latitude and longitude coordinates in our CSV file, but we need to geospatialize them into proper geometric objects that GeoPandas can work with. So first, again, similarly to what we did before, we're gonna import the Shapely points module, and then we're using a list comprehension with the zip to pair up our coordinates efficiently, and this will convert our separate latitude and longitude column into a single geometry column that containing points objects. And then we're gonna using the geodata frame function to geospatialize our normal pandas data frame into a geodata frame, and then we will set the coordinate system into WGS84 because we're using the GPS or latitude and longitude location. And once we've done this, we can again check our geospatialized data frame, and now we can see that we have a geometry column and it has the points or the geospatial information that we have. And next, we're going to do a buffer for all the cluster points. And this is because in the DHS survey methodology, the cluster locations are deliberately randomized by up to 10 kilometers from the original location to provide participants privacy. And to account for this uncertainty when extracting weather data, we need to create a buffer zone around each point. So to do this, first we're defining a function to convert kilometers to degrees. This is because we're working with on the WGS84 coordinate system, and the distance units there is degrees instead of meter or kilometers. Then we're gonna use the buffer function and put the distance parameters, and this will buffer our points to circle polygons. And however, you'll notice that we get a warning when we try to create this buffer. And this happens because we are working with, again, the geographic coordinate system, which measures distance in degrees, not kilometers. And when we try to create a buffer of 10 kilometers, the system will warn us that the result might be inaccurate because the degrees and kilometers aren't directly comparable. But since we have already included this km2d function to convert our distance into the degree units, we can ignore this warning. But again, this warning highlights an important principle in spatial analysis that we always need to be mindful of our coordinate reference system and how it might affect the distance-based calculations. So once we have buffered our DHS cluster points, now let's try to visualize our data to understand the spatial distribution of our DHS cluster. And this visualization will help us verify our data and spot any potential patterns or anomalies. So we'll first start by reading the heat index max layer for just one day, that is July 1st, 2016, and then we're using the rasterio function to open it. And we're going to use the show function of rasterio and also using the plot function to plot the point data on the same axis. And once we have done this, we can see that in this map, those black circles are the buffered cluster points across Ghana, and the underlying reddish map is the heat index. And this kind of visualization serves as a quality check, and we can confirm that our points are falling within reasonable geographic bounds and their good coverage across different heat index values in Ghana. And now let's run the zonal statistics for our DHS cluster. Similar to what we did before, first, we're going to create a specialized function called zonal that will compute the statistic for our heat index data. And this, we have also used the same function as what we did before when we were extracting the heat index value for different administrative divisions in Ghana. So this function will first handle the coordinate system alignment, and then it will run a zonal statistic to compute our specified statistic matrix that we want to calculate. And finally, we'll convert the statistic into a geo data frame and preserve the original CRS and return a GeoPandas data frame that containing both our boundary information as well as the statistic metrics that we want. So after we define our function, we can apply this to our specific case. So first, we select our buffer DHS cluster with only the cluster ID and the geometry column. And then we'll also load the heat index data for July 1st on 2016. And now we're computing the mean heat index value for each cluster buffer zone. And the resulting geodata frame will combine the cluster identifier with their corresponding heat statistics. So once we have done this, we can print the result data frame, and we can see that for each cluster, we indeed got an aggregated mean value of the heat index. And to visualize our result, we can create a side-by-side plot for comparison. So on the left, we're going to see the point data with colors representing the mean heat index value for each cluster buffer zones. And on the right, we can have our original raster data sets. And by checking this map, we can see that the map on the right hand will show the mean heat index value for each cluster point as specified by the legend, and on the right is the original heat index map. So finally, we can extend our analysis to look at heat index pattern across multiple days. And we're going to create a loop to process data for the first week of January 2016 and visualize the trends. So first, we're going to get a list of the first 7 days of the heat index image. So this is the first week of the heat index geotiff files. And then we're going to use a for loop to process the 7 days of data. And here, something I want to point out is that when we are working with file passes, we need to account for different operating system. So I'm using a Windows PC, so it uses the double backward slash as splitter for the file pass, but Mac uses the forward single slash. And in our code, this becomes relevant when we extract the dates from our file names. So you need to adjust the split character based on your operating system. So basically what this code do here is that it's splitting the file name into different pieces, and then we're trying to grab the date information from the file name. And here we add a print function to let the users know that we are starting processing the file for what date. And then you're gonna use the zonal statistic to calculate the maximum heat index using the zonal statistic function, and then we will rename the column to reflect the specific date. And finally, we're gonna merge the results with our previous date data. So if we run this code, we're gonna see that first it's telling us that it is processing on the 1st of January and then moving on to the 2nd of January, and it will run this for, it will print this for each file. And once we have done this process, we can check our output file. And in the output file, we can see that it is organized in a way that for each clusters, we have multiple date column that represent the maximum daily heat index for each cluster point. So we can see them from January 1st all the way to January 7th. And to visualize this temporal pattern, we can just create a simple line plot for example cluster 2. So first, we're going to use the pandas ilog indexing function to select the heat index value for this cluster. And we're selecting the second row and all the columns from the third outwards. And we need to start from the third column because the first 2 columns you can see here are the geometry and also the ID. It is only from the third column that we have the maximum heat index value. And for our x-axis, we will first format the date objects and to convert our date columns into datetime objects that Python can properly understand and plot. And here again, we're starting from the third column to skip the geometry and custom ID. And once we have done this, we can use the scatter function and also the plot function to plot both the line and points. And then the result plots, we're going to show the daily maximum heat index trend with the dates on the x-axis and then the maximum heat index value on the y-axis. And you can see that here we have a slight downward trend, which suggests maybe in the first week the temperature is cooling down on 2016. And that is all for today. I hope you enjoyed our session